morning, students. In the last class, I have discussed the hybridization concept. And I have given you some examples. Example given beryllium chloride, which involves sp hybridization. I have given you BCl3, sp2, methane, sp3. Okay, then if you know the hybridization, you can easily predict the bond angle. For sp hybridization, the bond angle is 180. For this one, it is 120. For this one, it is 109.5. Similarly, the geometry of the molecules, in this case, it is linear. Here it is trigonal pyramidal or triangular structure, and here it is tetrahedral. So all these types I have discussed in the last class. The beryllium chloride molecule involves sp hybridization, this involves sp3, and this involves sp3 hybridization. And once if you know the hybridations, you can easily predict the bond angles and also the geometry or shape of the molecules. Then I have given you these two molecules as homework, that is PCl5 and SF6. I have given these molecules for homework. What type of hybridization is present in this PCl5 and what type of hybridization is present in SF6. You have to mention here. What is the hybridization? What is the hybridization here? Then you have to mention the bond angles. You have to mention the shape of the molecules. Okay, so these two are given for homework. Now we shall go for some more examples. Let me also make it clear here that in all these cases, only bond pair of electrons, are involved in hybridization. Okay, there are some molecules where, in addition to one pair of electrons, the molecules also contain lone pair of electrons. In such molecules where there are lone pair of electrons in addition to one pair of electrons, such molecules will have irregular geometry. With distorted bond angles. Okay. In all these examples which I have given you in the last class, in all these molecules, only one pair of electrons are involved. But there are some molecules where the hybridization involves both one pair of electrons as well as lone pair of electrons. Okay, for such molecules, the geometry is distorted, and such molecules will have irregular geometries with slightly distorted bond angles. We shall do one examples. Let us take three examples: CH4, ammonia, and water molecules. I have taken three molecules. In all these three molecules, we have this sp3. Here, only bond pair electrons are there. Only bond pair electrons are there in this formation of this molecule. Whereas in this case, lone pair of electrons and three bond pairs. Three bond pairs of electrons. Here, all four are bond pair of electrons. Here, there are two lone pairs and two bond pairs. Bond pairs of electrons. I told you, if the molecule involves only one pair of electrons, such molecules will have regular geometry. Regular geometry. With regular bond angle, and it is equal to 109.5 because we have this sp3, the expected bond angle is 109.5. There is no decrease in bond angle since this molecule has regular geometry because it has only bond pair electrons. Whereas if you come to here, in this ammonia molecule, we have one lone pair of electrons along with three bond pairs of electrons. Since the molecule contains lone pair of electrons, its geometry is distorted and it has irregular geometry. Irregular geometry with slightly decreased bond angle, which is 107 degrees. Okay. The molecule has irregular geometry and the bond angle is also slightly decreased due to the presence of lone pair of electrons. If you come to here, there are more number of lone pairs. There are two lone pairs and two bond pairs. Since there are more lone pairs, this molecule has still less bond angle. It's almost 105 degrees. Okay, and it also has irregular geometry. Irregular geometry. So I shall give you what is the geometry in this molecule and what is the geometry in this molecule. Also, I shall explain you by taking these two examples. But for time being, you will remember that if a molecule has only one pair of electrons, it will have regular geometry and the bond angle is as expected. Whereas if the molecule has no pair of electrons, definitely it will have irregular geometries. Okay, and the bond angle also decreases. The bond angle also decreases. I should take up this ammonia example. Ammonia. Here, the central atom is nitrogen. Nitrogen. First, its atomic number is 7. Therefore, its ground state electronic configuration is 1s2, 2s2, 2p3, 1s2, 2s2, 3p3. Let me write. This is 2s. This is 2. 1, 2, 3. Okay. See, there are 3 hydrogen atoms which are combined with nitrogen atom. 3 hydrogen atoms are combined with nitrogen atom. Therefore, I require only 3 unpaired electrons. 3 unpaired electrons. Here we have 3 unpaired. 1, 2, 3. 3 unpaired electrons are there. Therefore, ground state electronic configuration is sufficient. You should not consider excited state. Excited state very rare because this itself, the ground state itself contains 3 unpaired electrons which are sufficient to combine with the electrons of 3 H atoms. 3 H atoms. So excited state is not necessary. Now these will undergo hybridization and get hybrid atoms 1, 2, 3, 4. The name of this hybrid atom is sp3. 1 to S. 1 to S is combining with 1, 2, 3. 3 to S. 3 to S. Therefore, the hybridization is sp3. S1, P3, sp3. So it is sp3, sp3, and sp3. And this sp3 hybrid atom contains one lone pair electrons, single electron, single electron, single electron. Now the electron by first hydrogen atom comes and joins here. This is the electron by second hydrogen atom. This is the electron by third hydrogen atom. Okay? This is the electron of nitrogen. This is the electron of first hydrogen atom. Electron of nitrogen. This is the electron of second hydrogen atom. Electron of nitrogen, and this is the electron of the third hydrogen atom. Okay? And here both the electrons belongs to nitrogen atom only. And this electron pair, which is not involved, in bond formation is called lone pair of electrons. The electron pair which is not involved in bond formation is called lone pair of electrons. So this is lone pair of electrons. Whereas this is one pair of electrons, because one electron of nitrogen combines with one electron of hydrogen and forms a bond. Okay, therefore this is called a bond pair of electrons. This is another one. This one. One electron of nitrogen and one electron of hydrogen, both are involved in bond formation. This is another H, and this is the lone pair of electrons. So this is the shape of the ammonia molecule. Its shape is pyramidal shape, and the bond angle is almost 107 degrees. Okay. If this molecule has no lone pair, suppose the molecule lone pair electrons there, the geometry of this molecule should be tetrahedral and the bond angle should be 109.5. sp3 hybridization there. N shape barbeku, tetrahedral barbeku, bond angle barbeku 109.5 barbeku. But in the sp3 hybridization ಈ molecule ಯಾವ shape ಬಂದಿದೆ, pyramidal shape ಬಂದಿದೆ. And what is the bond angle? The bond angle is 107 degree. All this is due to the presence of lone pair of electrons. So this is about the ammonia molecule. So ammonia molecule involves sp3 hybridization. Its geometry is pyramidal and its bond angle is 107 degrees. Okay, and also have the definition of lone pair electrons. Electron pair which is not involved in bond formation is called lone pair of electrons. Let us take one more example. Water molecule. If you take water molecule, Here the central atom is oxygen. Its atomic number is 8 and its electronic configuration is 1s2, 2s2, 2p4, 2p4. Now this is the ground state configuration. We shall write in form of boxes. This is 2s, 2p4, 1, 2, 3, 4, 2p4, 2s2 and 2p4. This is the electronic configuration of oxygen atom in the ground state. You can see here we have two unpaired electrons, and two lone pairs. There are two lone pairs and two unpairs. Okay, and this two unpaired is sufficient to combine this oxygen atom with two hydrogen atoms. Therefore, ground state is sufficient, and one should not consider the excited state. Now, these will undergo hybridization and will get 4 hybrid atoms. 1, 2, 3, 4. This is sp3, 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 sp3. 4 sp3 hybrid orbitals will get, and this contains one lone pair, this contains another lone pair, and this hybrid is a single electron. Now the electron of hydrogen atom comes and joins here, and the electron of another hydrogen atom comes and joins here, and like this the H2O molecule is formed. Okay, it's formed. Now you can see here this molecule consists of two lone pair of electrons and two bond pair of electrons. Two lone pair, two bond pairs. Since the molecule contains two lone pair of electrons, it again has irregular geometry. In this case, it is, you can have bent structure or V-shaped structure. Okay. The water molecule has a bent structure or V-shaped structure, and its bond angle is 105. This is the case of water molecules. And the structure is O, H, so this is the structure of water molecule, V shape or bent structure, and there are two lone pairs and two bond pairs. So a bond pair of electrons is nothing but a pair of electrons which is involved in bond formation. A lone pair of electrons is a pair of electrons which do not take place in the bond formation. Okay, that is the difference between a lone pair of electrons and bond pair of electrons. And all these things can be explained on the basis of Westphal theory. Valence shell electron pair repulsion theory. Valence shell electron pair repulsion theory. So these things are explained on the basis of Westphal theory. So this is a brief about the hybridization of molecules. So totally I shall do that. I have given the BeCl2, BCl3, CH4, BCl5, SF6. All these molecules have a regular geometry, and all these molecules involve only bond one pair of electrons. Okay? Whereas I have given the examples of ammonia and water. So these molecules have lone pair of electrons, plus one pair of electrons. Since they have lone pair of electrons, these molecules will have irregular geometry, and their bond angles are slightly less than expected bond angle. So these things I have explained to you regarding the hybridization and Westphal theory. Hybridization as well as Westphal theory. These two concepts I have explained to you. The other examples for this one is BF3. It is another example. For this one, you can explain CCl4. Both CH4 and CCl4 has same type of shape, same type of hybridization, and same type of bond angles. Okay. So for even you can take your carbon dioxide molecule. Carbon dioxide molecule also has the linear geometry with sp hybridization. So these are the other examples for sp, sp2, sp3. Okay. So in the next class, I shall do the ions. So far I have discussed about the molecules only. These are molecules. In the next class, I will discuss the hybridization of ions. Hybridations involved in ions I shall take up in the next class. I will take up two examples. One is NO3 minus ion and another is I3 minus ion. Okay? And also please remember that if you have any doubts regarding these topics, you can ask me through a WhatsApp group. Okay? Oh, thank you.